Hello, everyone, and good evening. Welcome to our second lecture in the Santa Cruz Past, Present, and Future of the Santa Cruz River Heritage Reach lecture series. I'm Ben Wilder, Director of the Desert Laboratory on Tumamoc Hill, and really excited and happy to welcome you all this evening, and I hope you're doing well. So this lecture series is focused close to home and really is presenting multiple perspectives on as we talked about in our last, in our first lecture with Julie Pearson and Gabriel Vega from the San Javier Walk District, the lifeblood of our community, and going back, thousands of years. And we're attacking this and thinking about this from a number of different perspectives. And what we're really going to focus in on tonight is the hard truths, the unfortunate realities that we need to grapple with when thinking about the future of this river. And these are, inconvenient truths in many perspectives, but they're really important. And we need to take the time to understand the history of the river, especially the more recent history in the last 100 years or so, which has been pretty dark in what's happened to lead to the current condition today. And I think that sometimes we almost kind of want to wish away the factors that are making restoration efforts so challenging. But we can't do that because they're harsh realities. So we're really fortunate to be welcomed this evening and to be joined this evening by Bob Webb. So Bob is a real incredible mind on all things deserts. He truly is one of the his specialties and expertise in terms of being one of the most knowledgeable people on so many issues in deserts is hard to match. So Bob had his career with the U.S. Geological Survey, and he was based here at the Desert Laboratory for the majority of his 30-plus year career, from which he retired from the USGS in about 2008 or 13, I believe. But that retirement sure as heck hasn't slowed him down. Bob is one of the world's experts on the Mojave Desert, the Grand Canyon, and the Santa Cruz River. In his retirement, quote unquote, he and his wife own Arid Lands Greenhouse, kind of on the southwest side of town. If any of you have any sort of a green thumb or interest in arid adapted plants or succulents, you absolutely need to go and visit Bob. It's a remarkable collection that he's expanding. He's also one of the experts of agaves in Baja California, and now I don't think can stop indulging himself in learning and growing South African succulent plants as well. But what we're really gonna focus on in this talk, of course, is the Santa Cruz River, and he'll talk about this, but I wanna just mention this book, Requiem for Santa Cruz, of which he is the lead author with Julio Betancourt, who is also with USGS, just retired and is based here at the Desert Laboratory, Roy Johnson, and Ray Turner. And that is not just a powerhouse of collaborators. And I think it's really important to mention that collaborative nature, and especially that partnership between Bob and Ray through so many years. And Ray was a dear friend of mine and mentor that we lost just recently. And Bob and Ray published monumental works throughout the years, and especially also on repeat photography, which is another thing that Bob is just a leader and pioneer on. So truly, the breadth of Bob's knowledge almost knows no limits when it comes to deserts and these topics. So Bob, welcome. Thank you so much for joining us. And I, for one, I'm just gonna sit back and have my mind blown here. I'm excited to hear what you're gonna say. And so thank you, welcome.
Hi, can you hear me?
Sure can.
Great. My name's Bob Webb. Obviously, I've got a PhD and I've had one for 35 years. And it's very strange for me to actually be in this room. I'm in the library at the Desert Laboratory giving this talk. And boy, I'm gonna guess it's 15 years since I've given a talk in this room, so it's kind of surreal. Maybe 20 years ago, I actually ran the lecture series out of this room right here. So it has a great deal of meaning to me. I wanted to just show you a few things about the history of this particular room with my camera here. Over in that area, when building 803 here at the Desert Lab caught on fire, Ray Turner, Julio Betancourt, and I all had our offices right over there. And then over at that door right over there, before this room was rebuilt and the floor was uncovered, there was a really nasty carpet. One day I found a rattlesnake over there right next to that door. So it was pretty incredible to see that. So some of our history is very personal, and some of it's kind of on the funny side, like that's encountering that snake over there. But other bits of our history affect whole communities. And that's what I want to talk about tonight, is history and what it means to us in terms of the Santa Cruz River. About a month ago, I opened up my Arizona Daily Star and I saw this thing, headline from a Tony Davis article, "Flows cut to the Santa Cruz River downtown to protect landfill." And I wondered, how has it possibly come to this? And the conclusion was, history was ignored, this river. But what I want to do tonight is to go through this. Ben has already introduced the book that I published as the lead author with some colleagues in 2013. I'd like to introduce those guys to you, but first, that title, Requiem for the Santa Cruz River, was Julio Betancourt's idea, and the definition of it is a memorial song of death. That might have been true in 2013. But now I'm wondering, could it actually be resurrection of the Santa Cruz River? And the definition implies revival from death. That's going to be the subject of my talk ultimately tonight. So here's those authors. Here's all 5 of us lined up outside of Bunny Fontana's home before he died. Ray Turner is somebody that's highly important in my life, meant just about everything to me. He has 62 years of professional experience as a landscape and plant ecologist, and he was the father of modern repeat photography. Roy Johnson has become a very good friend of mine, 62 years of experience as an ornithologist and riparian ecologist in various federal government jobs. Julio Betancourt, more than 39 years of professional experience as an ecologist, paleoecologist, and climatologist. He did his PhD on the Santa Cruz River. And then there's me with 45 years of professional experience in a whole bunch of different disciplines. All told, we had roughly 260 years of professional experience when we published that book. Now, unfortunately, Ray Turner and Bunny Fontana are deceased. It's a really big loss for all of us. It just shows you that we put a lot of our experience into this one book, and that's what I want to talk about mostly tonight, go beyond it. I stole this picture of the San Pedro River to ask the basic question of, what do we want from our arid lands rivers? There's really 3 things that I can encapsulate here. 1, we want water. We want to be able to drink it when we live in places. We want flood control so that we can build infrastructure like bridges and parks. And we want ecosystems for biodiversity. The real question of this talk is, can these 3 things really coexist in one place? So it's really impossible to say if we can have our cake and eat it too, but boy, we sure want to. So what I want to do philosophically is go through the following. Science is a discipline, which of course I participate in as a PhD in sciences. And then there's advocacy. I've played in that arena as well. And a lot of science these days is actually advocacy parading as science. And then there's engineering, and my degrees are all in engineering, so I can play in that arena as well. So it's interesting how these 3 disciplines or avocations, if you will, coexist until politics plays a role here. Well, there's politics involved in the Santa Cruz River, but I'm not going to really get to that tonight. What I really want to talk about is where those three things intersect, and that is the Santa Cruz River, how it fits together. First, there's a number of myths associated with the river that some people still hold, other people know are false. I want to go through a few of those. First one is Santa Cruz River was perennial its entire length. Nah, it wasn't. The only time it's ever really flown from headwaters to the Gila River was in, say, 1977, 1983, and 1993, maybe in 2005. Before 1878, the river had alternating perennial and ephemeral reaches that were related to groundwater discharge points. And that's where the riparian vegetation grew. The river was ephemeral in some pretty long reaches, particularly from Continental to Pima Mine Road, and then downstream from Marana to the Gila River. It was dry most of the time. So, myth. In the 19th century, the Santa Cruz River flowed at the surface through the Tucson Basin. No. There were head cuts present, indicating a discontinuous arroyo system, a channelization in certain areas with distinct banks that was alternating reaches of perennial and ephemeral flow through the Tucson Basin. We'll get to that. Santa Cruz River had beaver, large fish, and turtles in the Tucson Basin. Not quite. Beavers were only documented up near the border, near Nogales and upstream from there. And some water-dependent turtles were probably in the Great Mesquite Forest. We'll get to that place in a few minutes. And there were certainly small fish related that were localized into some of these places like 8 Mile Waterhole and up in the Great Mesquite Forest. So not continuously along this river. So what my group of collaborators and friends did was we assembled a large array of evidence, ranging from the anecdotal evidence. A lot of that was Julio Betancourt reading Spanish documents that were assembled by Rod Hastings. There were visual things that Ray Turner and I matched those photos, found the positions. And then there were quantitative measurements made, which is mostly my role in this particular book, was to put that information together. Bring it all together is really a difficult task, and it requires a lot of extrapolation and interpolation to do it well. And that's what we tried to do with everybody bouncing off of each other on this particular book. So here's a timeline of historical observations just to show you how some of this stuff fits together. Father Kino arrives in about 1700 and he leaves a record. Mormon Battalion passed through in 1847. They had a record of what went on because they had to water their horses at the Great Mesquite Forest and the Mission Santa Vera del Bac. Rainfall records began in 1868. First ornithologists arrive in Tucson around 1871. First photographs are in the mid 1880s or so. Newspaper accounts start up and they're documenting floods in the 1890s. Streamflow gauging begins in 1915. And then continuing on in the 20th century, ornithologists really flocked to Tucson starting in 1900 through the 1920s. Arroyo widening occurs and causes all kinds of grief in Tucson in the teens and 20s. Turbine pumps were introduced for groundwater withdrawal. We'll get to that one in 1920. First aerial photograph was 1936, and they've been continuing ever since. Mid-century drought occurred, and that's a big deal, and it's centered around the 1950s. Satellites were flown starting in about 1963, and that was just a record of various things, including storms that affected Santa Cruz River. Groundwater use peaks in 1980 with the Groundwater Act signed by Bruce Babbitt. Soil cement was installed along the Santa Cruz River starting in 1982. We'll get to that. 1983 flood occurred, a big deal. 1993 flood occurred, another big deal. So what I want to talk about first is how that arroyo downcut and what are some of the implications of it? Why did it happen? And what were the net results that we're still seeing today? This is a map from Julio Betancourt's dissertation. He's got it, what the Santa Cruz River looked like before 1880. It was a discontinuous ephemeral stream. What that means is that there were alternating reaches of perennial flow and ephemeral flow. you look at his map there, you're looking at the Santa Cruz River from just upstream of Martinez Hill on the Santa Fe district land, all the way down to below current day Marana. You can see the black sections are where perennial flow was, and the white sections are where it was ephemeral, where basically it was dry much of the time. So there were discontinuous arroyos in this section. Julio's marked some of them on this map. For instance, right about the point where I think Ajo Way would cross the Santa Cruz River, there was a head cut in 1871, and it was it intercepted the water table in 1882. Groundwater levels throughout the Tucson Basin were pretty high. We had artesian water just to the west of Sentinel Peak, for example. That's one of the things that had those two lakes over there, Warner's Lake and Silver Lake, right up at this particular point up here. And then there's a large cienega right down here that we call the Great Mesquite Forest, and we'll be talking quite a bit about that one here. So this is a lot of the information, annotations from Julio's dissertation, showing again, this is the Great Mesquite Forest down here, Martinez Hill. This is Santa Cruz River where it was dry. And then the West Branch, which took a lot of flow as well over here and has had some sort of restoration efforts on it, 2 lakes. And this is where Sam Hughes Ditch was. It's up around where Congress Street is today. So Santa Cruz River began downcutting and coalescing in the 1880s. The actual date, if you want one, is 1878, according to Julio's work. The downcutting and widening was associated with frequent or large floods. It was really sustained floods. For really, in 1890, we had flow in the Santa Cruz River that was unlike anything in recorded history before or afterwards. And it was something that just did a lot of channel erosion. Sam Hughes was a guy, we won't go into his history, but he designed a ditch to irrigate some land down near Grant Road. And that ditch was designed to erode during floods to create an irrigation canal. He'd rather do that than dig it out. Well, it went berserk, and it really cut the current arroyo that we see through town. So sometime before the year 1900, arroyo was continuously incised through the Tucson Basin. This is a photograph that shows a lot of that action in the 1890s. The photograph by Buman was titled Sam Hughes Head Cut, Taking a Walk to Silver Lake. And you can see a lot of active channel erosion with vertical banks in this photo and a lot of the riparian vegetation that was once in this area. So it's interesting what happens when you cut an arroyo, because along the Santa Cruz River, it was basically a broad, probably braided stream, maybe a distributary flow system set up. A lot of alkali Sacaton water and grass that was there that was feeding, say, the Mormon battalion, horses when they came through, as well as the livestock at the mission. When it downcut, it was initially a very deep and narrow trench. What that does is it drains the groundwater. So much of this riparian vegetation that we like cottonwood trees, it can't sit in open water. It's got to have an unsaturated zone below the root bolus. So you've got to actually drain down that groundwater, and that's what happened when arroyo downcut, and that's why those trees invaded the floodplains. Then during the widening phase between 1914 and 1930, it got a lot wider, and all that riparian vegetation went away, and the plants couldn't get down to that water table anymore. So we started to get non-natives like Aethel tamarisk, which are still in abundance along the Santa Cruz River. So I want to just briefly go into some causality here, because a lot of people have had opinions on this issue of why arroyos downcut in the first place. The number one cause, if you look in the literature, is livestock grazing. Another one is floodplain disturbance. Another one, which was really popularized in the 1980s and early 1990s for the Colorado Plateau, was groundwater declines due to drought. The idea, we'll get to it, is to exactly why that plays in. And then, of course, climate variability. But it really is important to pay attention to where the water's coming from and what it's doing, because it takes water to transport sediment. There's nothing magical here with livestock. Livestock have got to affect how water moves. And the hypothesis for livestock grazing is that overgrazing destroyed rangeland vegetation, increasing watershed and erosion, leading to arroyo downcutting. I came to Tucson in 1981 to do this for my doctoral dissertation. And I concluded exactly the opposite of that hypothesis. Why? Because there's some really basic problems with that hypothesis. First, there are a lot of paleo arroyos that show up in the banks of these rivers, including the Santa Cruz River, and there weren't any livestock around at those times. The second problem is more of a hydrologic watershed problem. If you increase runoff and sedimentation owing to livestock trampling and denudation of the hill slopes, that should cause sedimentation, not erosion. The arroyo should fill up, not downcut. The other problem is that there's not a direct relation between livestock and the watershed and when the arroyo is actually downcut. So there's some timing issues as well. So this one I think we can set aside. It obviously had an effect, but it was not the principal reason. And here's a graph that I've got. The lower graph calls livestock number information from the US Census of Livestock. And clearly in the 1890s and up to 1900, when there was a lot of arroyo downcutting, we were actually at the lowest levels of livestock in the watershed. And as I'll show you, there was a lot of action in the Santa Cruz River post the introduction of livestock here. So there's no clear relation between livestock and channel downcutting. People have talked about floodplain disturbance like Sam Hughes's ditch. He'd signed that ditch. Could that be the reason why there was an arroyo formed here? Well, not so fast, because not all the places that had arroyo downcutting actually had canals and ditches on them. And paleo arroyos, again, developed at times in the past without that, including the height of the Hohokam settlement of the Tucson Basin. Now, those canals in the Tucson Basin are still around in pieces, which means it did not act like Sam Hughes's ditch. Santa Cruz River didn't follow those canals. It actually cut them off and went its own direction. So it's unlikely that floodplain disturbance had anything other than a minor effect on the arroyo downcutting. The groundwater drought hypothesis is a very interesting one, and we'll get into this a lot during this talk, but basically it is droughts like the big drought that happened between 1891 and about 1904 lowers groundwater tables. There's no evidence that that actually happened, but that was the hypothesis, and that killed riparian vegetation. What that does is it decreases flow roughness in the channel, and the same size flood has a higher velocity and is more erosive to the floodplain. Well, the problem is with the Santa Cruz River, the groundwater level stayed high all the way up into the measurements on groundwater start in 1930 or so. So it only starts really declining for reasons we'll go into in the 40s and 50s. And then, of course, coming after 1970s, it really goes down. So my favorite hypothesis is, and will remain, the arroyo downcutting occurred during times of unusual floods, large size and persistent occurrence. This occurred region-wide between about 1880 and 1915, all the way through the southwest United States. Arroyo widening also occurred during persistent flooding, but generally of smaller size after that till about 1930 or so. And those arroyo walls became stable when we had the mid-century drought from roughly, say, 1938 to about 1964. The channel narrowed in response to the reduced flows. New channel erosion happened with renewed flooding between 1977 and 1993. We'll go through all of that. Here's the precipitation record for the University of Arizona, Tucson. We're very lucky here in Tucson when considering this because this is the longest precipitation record in the state of Arizona. And what it says is, this is the late 19th century wet period when arroyos downcut, and this is the early 20th century wet period when the channels widened. So we have a lot of evidence from the actual instrumental records for why this event occurred. So I want to talk about water for development now, because this becomes a key issue, particularly leading up to today. When I look at this, everybody sees history, they might see religion here. When I look at Mission Santo Vera del Bac, I see water, because it was built in this position because there was a stable surface water supply to irrigate the agricultural crops. That's why it's here. Here it is on this particular map over here at Santa Vera Mission. there. And upstream was where that water was coming from in this perennial flow region, and then in this perennial flow section here on a distributary flow arm of the Santa Cruz River. Think of it this way, in 1890, there were 5,000 people living in the city of Tucson. And those people got their water from surface water into small canals. Wagons hauled barrels of water in, and there was a little bit of shallow groundwater harvesting done with shallow wells. In 2012, a million people in town were now dependent on total groundwater as well as blended Central Arizona project water for all uses. So there's been a massive shift in where we get our water from here. This graph is very interesting for a lot of reasons, but I really just want to draw your attention to the fact that it's raising up, raising up, raising up. Groundwater law was put in at this point, whereupon we brought CAP water in. This was the disaster that was direct CAP delivery of water in the 1990s. And then finally, we went to blending groundwater out in the Avro Valley and delivering that in. So this is where our water, but just notice this incredible rise in this curve starting around 1930s and 40s, how we're just thirsting for more and more water in this town. And you can see why. Here's a photograph taken from Powder House Hill. I can actually see it from where I'm talking, looking straight down Congress Street, looking east, the Rincon Mountains in 1890s. Now this thing across the foreground, this is actually a canal with cottonwood trees growing along it. Well, that would have been eradicated by the 1930s. Congress Street moved a little bit by 1981, and you can see the houses coming in the Menlo Park neighborhood, and here it is in 2007. So this is the thirst for water, is all these people out there. Now, the arroyo was widening in the teens and the 1920s, and we'll talk about some of the reasons for that in a minute. This one, between 1930 and about 1977, the Santa Cruz River became a trash heap. The landfills all over the area near downtown, and trash was being pushed into the river because it was being treated like a giant flush toilet. And during this time, the river was trying to narrow, and with a narrow channel, but there wasn't enough water in there to really grow a lot of riparian vegetation. So this river was very complacent, nobody cared about it, and they started encroaching upon the floodplains. So flood control becomes a big issue. Now, in 1890, here again is the river flowing and down cutting the arroyo. And it's interesting to go through the historical records and to look at what was going on with this particular river. In the 1880s, the floods were damaging properties and flooding houses. Between 1890 and 1950, the problem was bridges being destroyed and properties damaged. Between 1977 and 1983, the problem was destroyed bridges and damaged properties. So for 130 years, it's been all about flood control on the Santa Cruz River, not riparian ecosystems. We've managed it for flood control purposes. And I'll show you a little bit why here. This is a 1902 photograph looking at the Congress Street Bridge over there. You're seeing the Catalina Mountains in the backdrop. This particular thing is a really wide meander bend going over to the east. I do believe that there's a hotel that would be actually in the water right now if you hadn't filled this back in long ago. This is a photograph looking towards Tumamoc Hill, where I'm giving this talk, Congress Street Bridge, showing the wooden nature of it, carriages going across in 1914 during a flood. And that same abutment, you can see now we're looking at Sentinel Peak over there. You can see that it's fallen down because of channel widening. One of the things that's interesting about floods is that when you talk to FEMA and you look at FEMA regulations, the Federal Emergency Management Agency, they're more concerned with rivers going out of banks and inundating places. What happens in the Southwest with a lot of rivers like the Santa Cruz is the problem is channel widening. You get these lateral swings and meander bends, and they take out bridge abutments, they take out property, they kill livestock. So between 1916 and 1977, that wasn't happening. It led to complacency in the population. History was forgotten, and development encroached on that floodplain. Hurricane Heather changed all that in 1977. It was not a very big flood. It was big enough to cause a lot of severe destruction in downtown Tucson. And as a result, they installed the dreaded soil cement. It was first installed just upstream and downstream of the Congress Street Bridge in 1982. And interestingly enough, in 1983, it had it mostly finished in that area. Good thing, because that led to this 1983 flood with soil cement on both banks. This is the flood that got my attention on the Santa Cruz River and held it for a lot of years. This big flood of 52,800 cubic feet per second, unprecedented in the history of this river. The thing is, that soil cement limited damages except at the beginning and end of protected reaches. That soil cement was the subject of a National Academy of Sciences report that my major advisor at the University of Arizona, Victor R. Baker, was the lead author on. So it was a pretty interesting, revealing thing about how we're protecting flood control. This is that soil cement downstream from the Congress Street Bridge. It's over there on the right in the distance. There's a sill that shows up in the middle of the channel. That's to limit down cutting and to prevent bridge abutments from being swept out. And then the soil cement over on the right foreground. So it's ugly, but it's effective at stopping damages and has through the 93 flood and actually the 2005 flood as well. So again, we're very lucky to have a huge amount of data on this river. This is the gauging record that I've spent years poring over for the Santa Cruz River at Tucson, Arizona. It's right at the Congress Street Bridge. What I've done here with this annual flood series, I've taken this apart in any number of ways, but I'm showing you summer floods in green, fall floods in red, and winter floods in black. If you look carefully at that, you'll see that those reds and black bars are clustered in time. So there's obviously something related to climate and climate variability that's going on here. Think of the poor guy that's got to figure out how to manage this river. Up until 1977, if you calculated 100-year flood for that gauging record right there, it's 20,380 cubic feet per second. You calculate it for this period, it's nearly 76,000 cubic feet per second. Depends on what your start and stop dates are. Then if you go over to this other one, it's again down to around 20,000 cubic feet per second in the last 20, 25 years or so. So what do you do here? FEMA requires that you use this type of analysis to design structures and to protect channels from floods. So what they did was, here's the 100-year flood estimates that have been done for this river. Back in 1938 or so, decided the 100-year flood was about 12,000 cubic feet per second based on the record up to that point. Well, with the 83 flood, what happened was decided to do a design flood to 65,000 cubic feet per second. That's downstream from the Rillito River. Then a regulatory flood of 60,000 cubic feet per second, 60,000 cubic feet per second through the city of Tucson with the river. So the soil cement is designed to contain 60,000 cubic feet per second, or basically the 1983 flood. So a little diversion here in the statistics, but there's something in time series analysis, which is what flood frequency analysis is, that in the time domain, you require an assumption of stationarity. What that means is that in type 1 stationary, mean and the standard deviation, or the variance, if you will, of the distribution does not change with time. Well, that's not true for the Santa Cruz River, which means that the Santa Cruz River flood frequency record is non-stationary. And that means the assumptions of flood frequency analysis are violated. The results vary widely depending upon what part of that data set you actually use. That's why Pima County went in and just established floods. They decided that this record could not be relied upon for design of floodplain structures, and they just put in their numbers based on their best guess as to what was good. And oh, by the way, global climate change is probably the best example now of non-stationarity of anything you want to think about. Think about our temperature record in the last few years. It's a classic non-stationary time series. So I want to show you the Congress Street Bridge again in 1914, I think that's the 30s, I can't see it, 1983, and then sometime around 2008 or so. Important things here is the 1983 channel is trapezoidal. This is the soil cemented channel, but you can see that there's a small terrace that's starting to develop here because of the flow. And by the time that I took this photo over here, it was encroached upon by riparian vegetation. There was a blackwood right up against the bridge, big mesquite trees, and a lot of native grasses that are on this particular floodplain over here. So let's go and look at this time series and see what goes on. Now, at this point in time, I would probably do this differently now, but in the point of time when I did this, Pacific Decadal Oscillation was probably the best climate signal we could use for influence on Tucson climates. And if you look at the hurricanes in the Pacific Ocean, you see that they actually are ramping up after that drought period into the wet period that is the 1977 through 1995 period, and then recently drought. And I haven't extended this out to the present day, but it's more or less the same thing. So there's a clear relationship between a global climate index, what's happening on the Santa Cruz River, and some of the things like hurricanes are affecting us. I want to go into ecosystems now because that's one of the other things that we really want from our rivers. So the thing about the Santa Cruz River, many of you may not realize just how important this river was at one time or another. Now here's a photograph that I took in 1903 in the 2000s of Congress, of the area just below the 22nd Street Bridge. What you can see here is really some small mesquite trees, not very impressive, with an eroding, ragged channel bank there. In the foreground of this upper photo, this is actually some primitive revetment along here, trying to stop channel erosion in 1903. Here it is with soil cemented banks, and notice the riparian vegetation is growing in there. There's sedimentation that's occurred. This is the Santa Cruz River at the Mission 22nd Street intersection, looking towards the Canca Verde, the Agua Caliente Mountain and Reddington Pass. You can see what I've been talking about. This is a little small mesquite bosque, very thick. It's up on an arroyo bank. It's up above the saturated zone here in the river. Those are cottonwoods back there along the Santa Cruz itself. So it's important that you have this unsaturated zone below those trees. And then by 1981, pretty much all you see out there for trees are Aethel tamarisk. And then here it is in the year 2000. I haven't wanted to climb up on the side of a mountain to match this photo recently. I'm getting too old for that kind of stuff. The Great Mesquite Forest was not in the city of Tucson, and it was a very, very important place. It was up here south of Martinez Hill. If you don't know where Martinez Hill is, it's where the I-19 bridge crosses the Santa Cruz River up on the Santa Verde district. In the 1880s, 1870s, it was a perennial reach, and the water was diverted over to Mission Santa Verde to feed the field. We know quite a bit about this because it was such an important feature back in the 19th century. It was a major riparian area. And the first observations on it from Pino and from the Mormon Battalion show that it was an open cienega with alkali saccatone grasslands. It was like a big donut, and the actual rim of the donut was a mesquite bosque with trees of enormous size. There were trees in there that were reportedly 4 feet in diameter at the base and 65 to 75 feet tall. When the arroyo downcut and drained the cienega in the 1880s and 1890s, what that did was encourage that riparian vegetation because it drained that cienega, and now the woody vegetation was able to encroach on that former cienega marsh area, if you will. So what happened was when this forest started growing up and became really dense, birds swept in, and it became a major place, a major touchstone for ornithologists between 1900 and 1940. So let's go through this a little bit more in terms of the history. Cienega was rimmed with mesquite, like a donut, if you will, with an outer halo of mesquite and an inner halo of alkali saccatone grasslands. There was a herd of cattle in there, but it didn't do anything to that particular cienega. The arroyo downcut 1880s and 1890s had lowered the groundwater table. Intensive wood cutting in the bosque was supplying Tucson with their heating needs. All that did was encourage secondary growth of the mesquite. Mesquite just kept on going. So between 1900 and about 1940, the Great Mesquite Forest was at its zenith. It was an incredible place. It attracted lots and lots of people out there, particularly ornithologists. So if you look at it again, this is a cartoon that shows that you had a cienega with a lot of emergent aquatic species. And then when you downcut it, you lower the groundwater table to the bottom of the arroyo. And that has this unsaturated area where the trees can now take root. This shows the net result of that in 1912. This is the Great Mesquite Forest, a photograph from Martinez Hill looking south of the Santa Ritas. There are several things in here that bear note. One is that's called the Indian Dam with a little diversion reservoir. They were still diverting water over to the Mission Santa Vera. There's an arroyo headcut, an arroyo wall right there showing that the arroyo was quite deep in this area. And despite that, the Great Mesquite Forest is thriving. And then over there, agricultural clearing is already starting to cut into the Great Mesquite Forest. So in 1936, when the first aerial photo was taken, this bosque occupied an area of 7 square miles. So this was not a small place in any way, shape, or form. Historically, there were 5 fish known from there, 2 frogs, a turtle, lots of snakes, and a clam. An actual clam lived in there. Mammals were less certain, but we're pretty sure that in addition to javelina and other things, were gray wolf and jaguar that were at least making this a stop in their hunting schedule. So Mesquite Boast was very famous, and ornithologists came in and made bird lists and recorded lots and lots of notes about things. We had more than 100 species of neotropical migrant birds, water birds, and resident birds. And many of these birds no longer are found in the United States and are on threatened and endangered species list. This used to be within a short distance of where I'm giving this talk. Here are some of those birds. Black hawk, for example, gray hawk, and the northern beardless perennial. The one that Roy Johnson was particularly fond of was the rose-throated Descartes. This was an extremely rare species that is no longer found in the United States, but it was in the Great Mesquite Forest. But if you look at this guy, white-winged dove, this kind of really sums it up in terms of what was out there. It was perhaps the most common species in the Great Mesquite Forest, and in 1922, the quote was that white-winged doves fairly swarmed through the thicket. Their tiresome notes were the dominant sound in the Great Mesquite Forest. Now, Arizona Game and Fish maintains a tamarisk reserve of all things on the Gila River for this species. The irony of that just drives me crazy. I want to give you this as to where this started with the destruction of this particular bosque. This is 1931, and the mayor of Tucson is testifying before Congress. I'm going to cut to the chase. Here's the mayor of Tucson, and his end quote is, "Our engineers have investigated the claim that there is more water than the Indians can ever use and more than Tucson can use for 50 years to come." Well, 50 years after this statement was made, the Great Mesquite Forest was dead. And from our book, we say the bosque withstood arroyo downcutting, agricultural clearing, and wood cutting. This unique ecosystem could not withstand those stresses combined with the lowering of the underlying water table. So again, it's about the water. Let's get back to this particular diagram. This is a well record, one of the longer groundwater records around here, starting around 1931 or so, and it's right near Valencia Road in the Santa Cruz River. So the top line up there, that top dashed line, is where the bottom of the channel was. And then the dashed line is the limit to which riparian roots can get to from the surface. So here is the possible zenith of the Great Mesquite Forest, right around 1940 when those Arizona Game and Fish photos were taken. And then here's the tipping point around 1970 when groundwater levels passed below the point that roots could no longer reach. Roy Johnson was out here between 1959 and 1970. He watched the destruction of this forest and he knew it firsthand. So again, this is kind of a diagram that shows a cartoon of it. You've got a high groundwater level in this upper diagram. You've got trees growing all over the place in a deep channel The water is extracted from the aquifer, the trees start dying, and once it gets lower below about 90 feet, it's the end. There's stumps out there. When I first went out to that area of the Great Mesquite Forest, I didn't know what I was looking at. All I could see were the stumps of these really big mesquite trees that were still out there. They hadn't been cut for firewood yet. So here's the whodunit. Who killed the Great Mesquite Forest? Was it Mullen Lane, who invented the vertical turbine pump in 1902, allowing aquifers to be pumped from below? Well, just as a little bit of an aside here, if you were to suck on a straw in a glass of water, and it was a really long straw, you could only suck for 32 feet maximum before the base of that straw would start cavitating. The water would literally start boiling. So your maximum from a windmill is only 32 feet extraction. If you've got a turbine pump at the bottom of a hole, you can extract water from unlimited depth, and we do from 1,000 feet or more in the Tucson Basin. So it's that pump that really made a big difference along the Santa Cruz River. Okay, back to our whodunit. Was it Mayor Smith who decided that he would pump water ad nauseum out of the Santa Vera district? Or was it our predecessors, the citizens of Tucson, who thirsted for more and more water without understanding the consequences to the ecosystems? My vote is it's the citizens of Tucson that just can't seem to understand how valuable our water is. And they just keep wanting more and more and more of it. So here's the consequences. This is Martinez Hill again, looking south of the Santa Rita Mountains. I showed you this photo before. Here it is in 1981. This is after the 1977 flood had made a severe widening across there. You still see some small mesquite out there, but that's pretty much vaporized by 2002 with the 1983 flood and further dropping of the water table. This is the Santa Cruz River, Martinez Hill. A little closer, look at a cottonwood gallery forest. It's right near where the Interstate 19 bridge is now. And there it is after 1983 flood with nothing left. We'll be back to that place. Now, what I wanted to do was to look and just see what was the importance of the Great Mesquite Forest? What other equivalent bosques were they? Because people haven't really studied mesquite bosques. They've really been concerned with cottonwood willow forests like the Bosque del Apache. One of them was actually on the Santa Cruz River as well, the Camaqui thicket, right at the Gila River confluence. We don't know much about it though. It really was never studied. The Gila River at the San Carlos River confluence, where San Carlos Reservoir is now, that was probably pretty big. The Gila River at the Colorado River confluence, that was a pretty big mesquite thicket right there as well. And now it's a tamarisk thicket. I want to go to the Colorado River Delta. So I did this work in 1904, found a map that was very interesting. They were trying to develop the Colorado River Delta, and they mapped the riparian vegetation of all things. And then Ed Glenn, the late Ed Glenn, with his graduate students, mapped it in 2004. So if you look at this, up at the top, cottonwood and willow really aren't the problem. Those numbers aren't that different from one another. If you look at this, 10,500 hectares of heavy mesquite timber was present mapped in the Colorado River Delta in 1904. Great Mesquite Forest had 2,000, or about 1/5 of the Colorado River Delta. 0 area in 2004 in the Delta and 0 area in the Great Mesquite Forest. So the Colorado River Delta, that's in Mexico. That's their disaster in Mexico caused by our water management. The Great Mesquite Forest is clearly entirely our fault and our loss. So I always like this word restoration because, see, it's a euphemism, and a lot of people use it for designer ecosystems that have little or no relationship to what was once there or how it functioned. I've seen it in deserts, I've seen it in riparian ecosystems, and it's typically applied to the Santa Cruz River. And it's advocacy. It's not necessarily science. And when you use that word restoration, and when you hear that word restoration, you should really ask, restore to what and what time period? Because that's what's usually not there in people's designs for restoration. End of rant. I now want to go to the Santa Cruz River filling up with sediment. So this black line right here is the trapezoidal channel that was put in when soil cement was installed. That took out this blue line, which was a much narrower channel. Again, it was a situation where up to that point, the channel was narrowing. What I did with my graduate students and other people was document the filling in of this arroyo system using a variety of different things from direct surveying to LiDAR measurement. And this shows that area. It's cross-section 4 is right here where the gauging station on the Santa Cruz River used to be. You can see that the active channel area is only about 1/3 of what the width of between the soil cemented banks was, with a lot of riparian vegetation in here, mostly native, with the exception of this tamarisk tree right here. So we were filling up the arroyo. So I need to go after a little set of terms here. Flow conveyance is the amount of discharge that a channel can contain. Roughness is resistance to flow. Basically, the higher the roughness in the channel, the less it can convey. So when you look at increasing riparian vegetation, that increases roughness and decreases conveyance. I'll show you that for the Santa Cruz River now. So this is a stage discharge relationship. This is what's used to actually measure flow in any river, including the Santa Cruz River. What we have here is the blue line, is the 1992 stage discharge relation, and the red line is the 2008 stage discharge relation. So I'm going to go walk you through this now. So for a stage of 10 feet, so that'd be 10 feet of water in the channel. Well, that amounts to about, say, 28,000 cubic feet per second of flow. If you were to look at the stage discharge relation in 1992, when there was essentially a barren trapezoidal channel there. However, if you go to 2008, when all that riparian vegetation got in there, it's about half or a little less than half of discharge can be conveyed for that same stage of 10 feet. So let's turn it around and look the other direction. So let's say you got a flood of 15,000 cubic feet per second. Well, in 1992, that would have been a stage of something like 8.5 feet in the channel. But in 2008, the stage of 12 feet, so about a 50% increase in the stage. The river was trying to go out of bank. And in fact, there was a flood that I'm trying to remember now when I heard this on NPR. I was going to work and they said, you know, there's a flood in the Santa Cruz River that's the size of the 1983 flood going on. I thought, that's impossible. I drove across and I noticed that it was flowing through the trees, and that's why it was so high, because it was almost up to the bridge because of the flow conveyance decrease as a result of the riparian vegetation. So essentially, here's the irony of it. You have a trapezoidal channel that's soil cemented in and fixed. Well, it was engineered for 60,000 cubic feet per second post-1983 100-year flood. You let the riparian vegetation grow and the soil, the sediment increase. Well, that encouraged, it increases the channel roughness, and now it can only convey about 30,000 cubic feet per second. And the irony was, because of drought, that became the 100-year flood. So all of a sudden, this river could still function. And that's where we ended up with on the Requiem for the Santa Cruz, was that particular fact. However, there was a solution that had to be made here because of the way that was designed. Remember, this was designed in accord with FEMA regulations, had to dredge, and that's exactly what started in 2018. They were dredging. Here's that flood, that photograph of the Santa Cruz River at Congress Street that I showed a panel of. That riparian vegetation and this big amount of sediment, well, it's all been taken out. But flow releases from 22nd Street have come in and grown a lot of riparian vegetation in here now. So dredging removed a bunch of mature things, including that black willow tree that used to be there and a lot of big mesquite. Some of it's grown back already after 1 year. And roughness after 1 year has already increased. So in other words, we're fighting attempts at flood control efforts in the city of Tucson by releasing flow at 22nd Street. Here's the photograph that I showed before, the Santa Cruz River downstream from the 22nd Street Bridge. Here they haven't dredged yet. You can see the flow in the river is associated with those flow releases and some riparian vegetation growing. Look at the bank here that's in place that's grown since 2001 as a result of the low floods in the river. This is a possibility of it if we had another Hurricane Octave, it could go out of bank here. Now, this has got to be the worst diagram ever made of a cross-section of a groundwater system. I threw this together in a big hurry because what's going on here is you put a lot of water in that channel and it comes down and it hits an aquitard very shallow under the surface of the ground. So this is why the Tony Davis headline of threatening a landfill. It's not going down to China, it's hitting an aquitard. Remember, the area around A Mountain, around Sentinel Peak, had perennial flow in the 1870s. The reason was that there's a confining layer at shallow depth that was forcing water to the surface. So what we've done is we've just reactivated that, and now it's forcing water to the surface. So let's look a little bit at what the future might hold. Downstream of the Roger Road treatment plant, they're releasing water. This happens to be a photo looking downstream from Ina Road at the Santa Cruz River with all that wastewater that's being discharged into the river. Here, you've got a really nice little linear riparian ecosystem. It doesn't even fully occupy the area between the soil cement. So this is what's to be expected. Plus, it's a really narrow, deep channel with a lot of sedimentation because the riparian vegetation traps sediment and causes aggradation. This is what you could probably expect if we were able to allow that 22nd Street discharge to continue for any length of time. This is my preferred alternative. I happened to notice this as they were building a shopping mall on Irvington Road. What they were forced to do here was to do something about flood control on the Santa Cruz River. The shopping mall is over to the east of this point. What they've done is put in low cement banks, soil cement. What this does is it minimizes channel widening through these lower flows, and there's the high banks. This river, this particular channel can convey any amount of flow that could ever be. This could do Noah's flood, probably, in this particular channel bank. But if you're going to grow riparian vegetation in here, you've got to water it. So, conclusion number one, if you're going to do water releases at 22nd Street, you better put in high setback levees downtown. So sorry, it's going to have even more of an artificial look than it's got now. Sure, there might be riparian vegetation in the channel, but with that riparian vegetation, flood hazard is going to increase with time. And there's going to be a yin and yang here. There's going to be a push to pull that riparian vegetation out in order to maintain the flood control of the design flood, Pima County Regional Flood Control District. I want to finish this talk on a really happy note. Because about a year ago, I was invited out to that area near the I-19 bridge over the Santa Cruz River, right at the base of Martinez Hill. And a very interesting thing is going on there in that area that we use really to title our book, Requiem for the Santa Cruz. There was flow coming into the channel. What was happening was the CAP water being used on these agricultural fields over here is actually raising groundwater levels here. Again, it's a shallow aquifer here. There's something that's forcing water to the surface. That's why the mission was built here, was because water was being forced to the surface, and we've reactivated it with CAP discharges. The water's starting to flow down here, and when I visited this area in the company of a number of people, there were cattails in the channel. There was black willow volunteering. There were cottonwood trees, little cottonwood trees everywhere. So the question is, are we having a return to this great mesquite forest? I took this photo about a month ago looking under the I-19 bridge. Those green plants out there, those are what's known as dog-eared cottonwood. They're called dog hair cottonwood, rather, because they're so dense on that floodplain. There's hope here for what's going on. It's another artificial but unintentional consequence of our water management in this part of the world. And this one could be very interesting as it plays out, because this one's not going to inundate any landfills. So it's going to keep going, it looks like. So turning to the basic question of this talk, what do we want from our arid region rivers? Well, a requiem, these are the mud flats that were Great Mesquite Forest back around the turn of the century up to about 1940. Or we have resurrection, which is what's going on right now at that I-19 bridge over the Santa Cruz River. What is it going to be? With that, I'm finished with the talk and I'll take questions.
Absolutely excellent, Bob. Thank you. Thank you. You spelled out the irony and the contradiction of what we're facing here, you know, flood control versus having an intact riparian system. And thank you for that historical context. So if you all have questions, please put them in the question and answer box there. You'll see at the bottom of your Zoom screen on the far right. And then I will be kind of moderating the question and answer period and asking Bob questions. Just so you all know, time-wise, we've scheduled this towards to end at 7:30. We don't necessarily need to go that long, but we definitely have some time here to get into some back and forth question and answers. I'll just kind of kick us off here. Bob, what do you see as the best possibilities, if any, within the heritage reach? So focusing on the outflows that are happening at the 22nd Street Bridge and going right through down by the landfill there and going through under the St. Mary's 6th Street Bridge at the area of Tucson's birthplace adjacent to downtown. How would you suggest to balance everything you just described in terms of trying to think about urban revitalization in the core of our city, but realizing the flood control challenges?
Well, first thing I'd do is get those landfills out of there. I think they need to not cover them. I think they need to just get them out of there. So the first thing would be not capping it with dredged sediment from the river. Just remove the landfills altogether. Second thing is setback levees. That's something that's been done as a result of the 2005 and the 1993 flood down near Marana. They had to build extra setback levees to literally widen the top of the channel so that you could contain the flood flow. I think you could do that in a reasonable way. And I think there's some places where that's already been done. So those are the two key things that would be needed if you wanted to grow riparian vegetation and maintain the integrity of the flood control system. Okay, but the problem is that the push is going to meet shove at some point. If you grow vegetation like what's downstream of the Ina Road treatment plants right now, at some point, got to maintain it.
And what stretches of the river, both upstream and downstream, are these constructs or constraints alleviated in terms of having that kind of wider elbow room, you could say, for the river?
Well, there's a lot of parkland. Pima County is actually, and the city of Tucson has actually done some very good things with establishing parkland on both banks of the river. So that parkland could then be modified with high setback levees that are actually grassy knolls, if you will, or even desert knolls. It could go all the way down. Clearly, it's got to go down below the Rieto confluence because you have to maintain that. A lot of the damage that happened in 1983 was in the area between Grant Road down to the Rieto River confluence. That's why there's a lot of soil cement in that particular area. So that's what really has to be done. But I would really like to ask another question. Why are we doing this up in the Great Mesquite Forest? How come we're not just using that? Nobody's getting flooded up there. There's no landfills up there. And it's doing it on its own. It's the coolest thing I've ever seen. I literally had my jaw drop almost seeing all this cottonwood that was volunteering up there, and black willow as well. Why aren't we doing this up there?
And that was, and both Julie and Gabriel kind of touched on a little bit about how their efforts with the San Javier Co-op Farm are affecting directly what you're talking about. One quick question, clarification for you, Bob. Can you just define setback levee for everyone?
Well, it would be levees that are probably, I mean, it's hard to say, you'd have to do some flow modeling, but it would be set back maybe 50 to 100 feet away from the top of the current soil cement. And the height of it could only be 3-6 feet, hard to say. That's what setback levee is, a setback away from the channel. It's commonly used in flood control all throughout the United States.
Thank you. Diane asks you that, I'll just quote the question here. You obviously have some strong opinions. How much influence do you have with the people who are in a position to make decisions on how to manage the Santa Cruz?
Yeah, I'm a retired guy. I don't have any influence whatsoever. I mean, if they want to listen to me, that's fine. I'll be more than glad to talk to them. But you know, my life's gone elsewhere these days. So there you have that.
Well, this presentation is being recorded, so we can share it far and wide. Charlie asks, was the area currently occupied by the landfill part of a historic cut, or was it excavated for the landfill? That's a good question, Charlie.
No, what they did for a lot of these landfills was that they needed to narrow back down the river in order. See, the problem was the channel was widening and taking out the abutments of bridges, particularly the Congress Street Bridge, very important bridge. So they would fill it in with whatever they could, and they filled it in with garbage, as well as just any kind of material that they could come up with. So yes, it was part of trying to get the channel back so that they could keep a bridge intact.
Related to the landfills, Lily asks, have the landfills leached into the Santa Cruz River previously or at this time, or do we expect that to happen going forward?
I don't think it's going to happen from the surface. There's not enough rainfall in most years to do that. Plus, those landfills have been tapped. The one that's on Tumamoc Hill property, for example, has got a pretty high cap on it. So rainfall is not going to go into that. It would only be what they were worried about in that Tony Davis article, just water coming up from below.
Right. And are we at that stage yet?
No, they were just worried that it could happen because it was rising very rapidly. Again, it was being affected. I think they were thinking that, well, the water's going to just go to China, you know, if it infiltrates into this aquifer, and they weren't cognizant of the fact that there was a reason why there was perennial flow in that area and not downstream of that area. It sank back into the sand downstream of the road.
And that's all directly related for the inflows coming from the Santa Cruz, the Heritage Reach re-inflow project by Tucson Water in the county starting about a year and a half ago.
Yeah, it's basically mimicking what the natural flow regime of the river was. That's how the groundwater aquifer operated.
Yep.
And now.
Larry Venable asks, recently there's been massive bulldozing of the channel both south of A Mountain and between Grant and Camino del Cerro. You referenced this in your talk. Is this necessary? And what are the impacts on the river and biodiversity with that dredging?
Well, the impacts on biodiversity, that's the easy answer, wiped it out, right? That was the dredging that was needed to increase channel conveyance back to that 60,000 cubic feet per second design flow, which is what Pima County convinced FEMA that they needed in order to protect the city of Tucson. It had to be done, basically, according to law.
How much time, there's a follow-up I'm asking, how much time did that buy, I guess, to allow vegetation to return?
Well, that's an excellent question for which I have no answer. One of the things that I've been interested in with looking at what's happened at Congress Street is that, again, we've turned the water off now, but when I was viewing it after about a year, there was a narrow little channel cut there by that flow, and then a couple of terraces that have been built up there supporting riparian vegetation. Riparian vegetation and sedimentation could happen rapidly. Actually, it did happen rapidly from 1993 to 2008 when I last monitored that river. It's fairly quick.
Yep. Yeah, just a little preview. So we're going to get into that a lot more when we get to our December lectures, especially hearing from Michael Bogan, who's been studying the aquatic ecology of the results of just add water, as you said in your talk, Bob. Lisa Shippick asks, what would be your vision for enhancing the floodplain to support the Santa Cruz River ecosystem, specifically between Martinez Hill and downtown Tucson?
You know, the problem is that in downtown Tucson, like right over where I'm looking right now off of the Desert Laboratory, you've had a lot of infrastructure that's encroached upon that floodplain. Now we got Caterpillar down there, right? We got all these bridges down there. That's infrastructure, costs millions of dollars. It has to be protected. There's just no two ways about that. What I, again, would advocate is look up at what's happened at Irvington Road. What they did up there, the contractors for that shopping mall didn't care once they built the canal cross section. If they'd have dumped water in there, they could have a nice little mesquite forest down in the bottom of the Santa Cruz River up there. You've got to increase the channel cross-section to increase the conveyance. Otherwise, you've got a raging flood hazard. It has to be dealt with.
Sandra asks, how does the restoration at Canoa near Amado, so this is upstream now, affect what is happening in Tucson?
It probably doesn't have a huge amount of effect. One of the things that's interesting when you look at river theory, and I've done this for the Colorado River, we talk about the fact that the dams disconnect the river, cut it into segments, and continuity of the river is compromised as a result of that. When you have a discontinuous ephemeral stream like the Santa Cruz River, it has different reaches that function completely differently. So reaching up at Amado, maybe there's cottonwood seeds that are coming down from there, which would be great. I think the cottonwood seeds they're growing now at the Martinez Hill site are probably local. The question really there is, where's that black willow coming from? Now that also could be from Amado and carried down in small flood, or it could be blown in. It's hard to say. But tracing where some of those native riparian trees are coming from up in the new Great Mesquite Forest, if you will, that to me is a really excellent science question that really somebody needs to look at.
Kind of getting into somewhat related, Jonathan Goldman asks, it's kind of related to the beavers we were talking about earlier. Is it possible that beavers were present in perennial reaches or upland areas in pre-European times?
Yeah, absolutely. They're documented at the U.S.-Mexico border on the San Pedro. They're probably also at the U.S.-Mexico border on the Santa Cruz River going up into the San Rafael Valley. Absolutely. And one of the big controversies was just how much did beavers actually control the cross sections for channel down cutting? There's some people out there that are floating a hypothesis that extirpation of the beaver for hats in the 19th century was one of the reasons for arroyo down cutting. I don't buy that because obviously some of these desert reaches like the Santa Cruz River through Tucson, there were no beaver here. There's no documentation of that. There might have been muskrat here, not beaver.
A couple great questions just come in. This first one's relating to the Great Mesquite Forest we're talking about. It's from Denny Seymour. I'll just quote, are you aware that the Sun Javier Walk District has invested a considerable effort in getting those trees to grow in the former Great Mesquite Forest and in raising the water table by infusing CAP water into the aquifer? I think you did address that in part. I missed what you meant. Are you suggesting putting a second level of levees in the walk area district region?
I didn't understand that last part.
I'll just repeat. Are you, she was wondering, are you suggesting putting a second set of levees in the walk district?
Walk district?
The San Javier district. The San Javier district.
No, absolutely not. You don't need any protection up there at all. There's nothing actually, channel's so wide at that area for a variety of reasons I don't want to go into. There's no possible way that riparian ecosystem up there is going to cause any kind of overbank flow. So I think it's an ideal place to grow riparian vegetation. Absolutely ideal.
So let's go from Ronnie. What could be done with the landfill material? We're talking now back into the Heritage Reach area. Isn't that a huge amount of earth garbage to move? And what would that cavity do to the river?
Well, you'd fill it back in, obviously. But, I think the important point is just to excavate the trash and get everything out of there that's possibly toxic and could pollute the water supply. Yeah. It's actually not that big of a job compared to some of the things like the Atlas tailings pile that's been removed up at Moab. That was a big radioactive waste dump that was pulled out of there. So it's I would say engineering wise, it is not a difficult task to move that out and to fill it back in.
Lisa has a follow-up question saying, what other stretches of the Santa Cruz River would you suggest outletting reclaimed water in addition or instead of the Heritage Reach?
Again, my advocacy actually going back a decade or more has always been up on the Santa Javier district. That area up there, I would have put it in at Pima Mine Road and let it go all the way through that particular area, because what would happen there The thing that's interesting is you have to pay attention to the subsurface geology in this area. It just so happens that that heritage reach happened to be in an area that was perennial flow because of the subsurface geology. So if you were to say dump it in below ground road, for example, you wouldn't get much bang for your buck there. Dumping it in from the Ina Road and the Roger Road treatment plants, right downstream from the Gila River, the Rito confluence, again, there was subsurface geology that had water up near the surface. As you move towards Marana, as we all know who know anything about that reclaimed water, it's sinking into the aquifer because it becomes more sandy down there with less confining zones. You have to pay attention to the subsurface geology. And actually, that subsurface geology in the Tucson Basin, surprisingly enough, isn't very well known. It is out in the central well field, not over here next to the river.
Interesting. Linda asks, is there a way to redesign the inflow so it enters upstream? The channel seems much wider at the county's Paseo de las Iglesias restoration, just south of the current inflow.
I can't answer that question. I don't know those details.
Fair enough. I think this could perhaps be our last question. So if anyone has any more, get them in now. Because, and this is a good one to ask to kind of close that. I think it zooms out a little bit. Josh asks, what can we learn from the history of the Santa Cruz River to inform how we manage and ensure a healthy San Pedro River?
Oh boy, he really hit it with that one, didn't he? Yeah, well, if you could transpose the history of the Santa Cruz right over and, take it forward about 50 to 75 years, and there you've got the San Pedro River, okay? It's the same kind of things with groundwater pumping, although with Fort Huachuca and the city of Sierra Vista, groundwater pumping is actually between one of the principal watershed areas, the Huachuca Mountains, and the river. So what you're doing is tapping into the flow of the San Pedro from the west, stopping it. Now, the estimates I've seen for how long it'll take before the Sierra Vista, Fort Huachuca water will affect the San Pedro flow is anywhere from 25 to 50 years, more likely closer to 50 years, and at the rates that were going on maybe 10 years ago. In the case of the Santa Cruz, history is that Mayor of Tucson was advocating pumping right out of the Santa Cruz floodplain up in the Santa Fe district. So they're taking it right out of the river itself, not from between a headwater recharge area and the river, right out of the floodplain. So as long as that's not happening, at least there's a grace period on the San Pedro. I think that the writing's on the wall there. I mean, one of the things, I've looked at the San Pedro, written a book that talked about the San Pedro. It's been a good news story up there, but it isn't going to last. Writing is on the wall for that ecosystem as well.
Bob, thank you. This was really important and an incredible amount of information you were able to share in a short amount of time. I really, really appreciate you taking the time to connect with all of us. So for the over 130 people that would be giving you a loud set of applause right now, I will communicate that for everyone. So thank you all for joining us. In about a month, we are going to have our next lecture, which is going to be giving a very different perspective, and this is going to be the artistic view. We're going to be very fortunate to be joined by Dennis Caldwell, Kathleen Velo, and Kemi Eisel, three really distinct and well-accomplished and very well-renowned artists, and who have a lot of different experience with the river. And then again in December, we're going to be having two back-to-back lectures connecting science and management and taking a lot of what we've learned tonight and throughout the rest of the lectures. Please look at if you want to watch this again, which for those that are studying the river, I imagine you probably do. And please do share the link in the chat box. We have the link to the homepage. And also please do fill out the survey to let us know how you're enjoying this virtual experience until we can come together in person again. Thank you for sharing your evening with us, and take care till next time. It's great to welcome you all and for us to just continue to learn. Bob, thank you again, and good night.